So next we are going to discuss the Avogadro hypothesis. See, this Avogadro hypothesis, it's given by Amedeo Avogadro. Amedeo Avogadro is a Italian scientist. The life period of Amedeo Avogadro is 1766 to 1856. He born in the year 1766 and died in 1856. This is the life period of Amedeo Avogadro. So, what he explained? He given the relation between the number of molecules and the volume of gases. So, the famous Avogadro law, he explained as the equal volume of all gases under the same condition of temperature and pressure. He explained what every volumes, it has the same condition and the temperature and pressure contain the equal number of molecules. Okay. Then, what is the importance of Avogadro law? The deducing atomicity of gases. So, this is expectable 2-mark question. Even in 2014, they are asked the importance of Avogadro law, deducing atomicity of gases. What is atomicity? See, atomicity means the number of atoms present in one molecule of an element. What they said? The number of atoms present in one molecule of element. For example, nitrogen N2. That means the two nitrogens present, the number of atoms present in one molecule of element. Okay, that's the first importance of Avogadro law. Next, the importance is the establishing the relation between the vapor density and the molecular mass. So, next we are going to discuss the relationship between the establishing the relation between vapor density and the molecular mass. Okay. So, Avogadro law definition is a very important part. So, equal volume of all gases under the same condition of temperature. It has the same temperature and pressure, and then equal number of contain the equal number of molecules. Okay. Then, so already I explained the atomicity. So, atomicity means the number of atoms present in one molecule of an element. Okay. Based on depend on the atomicity, the molecules, it has monoatomic, diatomic, triatomic and polyatomic molecule. What is monoatomic? Then how we are going to find out the atomicity level? So, it has the standardized formula. The atomicity, it is equal to molecular mass divided by atomic mass. Okay. For example, now I am going to ask, find out the atomicity of chlorine. Okay. So, here I given the atomic mass is 35.5 atomic mass. Then the molecular mass is 71. So, find out the atomicity of chlorine. So, what is the formula we used? Atomicity equal to molecular mass divided by atomic mass. The molecular mass is 71 divided by atomic mass is 35.5. So, what is the atomicity level of chlorine? 2. Okay. What is the value? 2. So, this is what in 2 marks they asked. Find out the atomicity of chlorine. If atomic mass is 35.5 and the molecular mass is 71. So, you write the formula atomicity equal to molecular mass divided by atomic mass. Okay. Then again I am going to give another problem. Find the atomicity of ozone. O3 refer as ozone. Okay. Here I give the atomic mass is 16. Then molecular mass is 48. So, what do you do? Molecular mass, the formula is atomicity is molecular mass divided by atomic mass. 48 divided by 16. So, what is the atomicity of ozone? 3. What is the answer is 3. Okay. So based on this, we use this formula atomicity. So the atomicity formula is atomicity equal to molecular mass divided by atomic mass. Next, here I am going to explain the atomicity and number of atoms per molecule and example. See, so depending on the number of atoms, the molecules are monoatomic, diatomic, triatomic and polyatomic. I said, see there, monoatomic. Depend of the number of atoms present in the molecule. Mono means it has single one. Okay, so it has one atoms per molecule. Okay, see there, example, helium and neon. Helium and neon. Even if you refer the periodic classification, you find out the single, the monoatomic molecules, the atoms has single atoms. Then diatomic, di means two. See, it has two atoms per molecule. Hydrogen H2, chloride Cl2, it has 2H, and chlorine it has 2 Cl, 2 chlorine. Next, triatomic, triatomic means 3, it has 3 atoms per molecule. O3, that means ozone, O3, the oxygen combined with O2, oxygen combined with oxygen, O2 plus O, it formed O3, ozone layer. See, these ozone layers are naturally formed in the atmosphere. Polyatomic, that means the atoms of per molecule it has greater than 3. So, P4 and S8, phosphorus 4, sulfur 8. See, I am going to explain this, the equation. Nitrogen reacted to the oxygen, it formed nitrogen oxide. Okay, nitrogen oxide. That means 1 volume of nitrogen, 1 volume of oxygen, it reacted to form 2 volumes. So here we apply the Avogadro law. So Avogadro law, it's based on, it's explained deducing atomicity of gases. See, what they said, this is nitrogen is considered 1 molecule. Oxygen is considered as 1 molecule. So this nitrogen and oxygen, it formed 2 nitrogen oxide. That means it formed 2 molecules. So what conclusion they given? What conclusion they given? It is found to be 2 molecules of nitric oxide contain 2 atom of nitrogen and 2 atom of oxygen. Then after applying the Avogadro law, they said these 2 atom of nitrogen and 2 atoms of nitrogen, oxygen should come from 1 molecule of nitrogen and 1 molecule of oxygen. So therefore, it is called as the nitrogen and oxygen is considered as diatomic, okay, molecule. So it is called as a diatomic molecule. Okay, so this proves the atomicity of nitrogen is 2 and atomicity of oxygen is 2. So next we are going to discuss the relationship, establishing the relation between vapor density and molecular